Hello everyone. Today we are going to discuss another practice problem on dynamic programming. We'll be discussing Leetcode problem 64, minimum path sum. So I'll quickly explain the problem statement first. It states that we start from the top left corner and we have to reach the bottom right corner. Now, in going from top left corner to the bottom right corner, whatever path we take, there is going to be a cost associated with that path, and that cost will be equal to the sum of the cells in that path. So our objective is to find the minimum cost in which we can reach the end starting from this first cell. Now, I would highly recommend you to pause this video and try to come up with an approach. This problem does not use any new concept as such and only combines everything that we have learned in this series till now. So now let's discuss the solution for this problem. So first we'll try to solve it top down. And for explanation, let's take an example grid. It's again a 3 by 3 grid. And we'll give some names to the cells for our ease. So let's say that this is A, B, C, D. Now we start from A and our objective is to reach D. And the question also specifies that from each cell we can either go right or down. So from A we have two options. So we can either go to B or we can move to C. So first let's define some variables. Let's say cost A is nothing but cost of cell A. Again, cost BD is minimum cost from B to D. So cost BD is the minimum cost of reaching D from cell B, and cost CD is minimum cost C to D. Now what is going to be cost AD? So cost AD can either be cost BD, that is minimum of cost for reaching from B to D, plus cost of A, or second option is it is going to be equal to cost CD, that is minimum cost for reaching from C to D plus cost of A. Now these are the two possibilities that we have. Now in this we can easily see that cost of A is common. So the thing we need to minimize is cost BD and cost CD. So out of these two costs, whichever is the minimum, we'll obviously choose that step. So let's say if cost CD was minimum, then we'll obviously jump to CD, and from here we'll travel to D. So our choice whether we want to jump to C or whether we want to jump to B will depend on the cost of reaching D from B and cost of reaching D from C. Now, one thing which we can notice here is that if somehow we had these two costs, it would have been really easy to calculate the cost from A to D, the minimum cost from A to D. The only thing is that we need these two costs. Because once we have these two costs, there's nothing much left to do. We just have to find the minimum of these two and then add cost of A in that to get our final answer. So again, the king of intuitions will come in handy here. Since we are solving recursively, we will delegate the task of solving the subproblems. So subproblems here are cost BD and cost CD. So these subproblems we'll be delegating to our recursive method, and the recursive method will return us the correct answer for these subproblems. We don't have to worry about how. We just need to take care of the current step after the recursive method returns the correct answer for these subproblems. Now talking about the base case is pretty simple. When we have finally reached the last cell, what will be the cost from here? Simply the cost of the cell, because that we have to always pay and we do not need to take any more steps after that. So this is a fixed cost that we would have to pay in any path. So once we have reached this last cell, it is going to be base case. We are going to simply return 1 from here. Now, frankly speaking, I had no idea that this recursion intuition is so strong and can be directly applied to so many problems. It was only while making these videos that I realized how useful it is and how much it simplifies a problem. So in case you're not aware of this intuition, I highly recommend going to the recursion intro video and watching it. I'll attach the link somewhere on the top right corner of the screen. Moving to the implementation. So now I was a bit lazy, so I wrote only one code for memoization and recursion. So we will first use it to understand recursion and then make minor changes to make it memoize. So let's go through the code first. So first of all, we defined our helper function. Now helper function is responsible for returning the minimum cost from that particular cell to the end cell. So if we are at cell I comma j, then it will return the minimum cost from I comma j to the last cell. So as we have already discussed our recursion intuition, we will first delegate the task to the recursive method to solve the sub problem. So the sub problems is we can either go down by one step or we can either go towards right. So our recursive method will solve these sub problems. We don't have to worry how, but it will return the minimum cost from this cell to the final cell. Once we have these two costs from the recursive method, we need to take care or do the operation for the current step, which we have already discussed is nothing but simply taking the minimum of these two costs. Whichever cost is the minimum, we'll take that path and we'll just add the cost of the current cell because that we anyways need to pay. So minimum of these two plus the current cell cost will be the minimum cost from this cell to the end. So we will simply return the answer from here. And as we have already discussed, our base case is simple enough. When we have reached the last cell, we just return the cost of that last cell because there are no more steps after that, and that cost we have to anyways pay. And this is just a condition to keep the algorithm in check, so we don't have to go out of bounds. We don't want to go out of bounds. So whenever we have gone out of bounds, we have just written integer max as the cost, because integer max will never get picked. There will be something smaller than this, so this is the maximum value in a integer. So obviously this recursive solution is going to give a TLE error. Now we have already drawn the recursion tree for a similar matrix question in the unique paths practice problem. We know that the solution is going to have overlapping subproblems. And in case you're not able to appreciate this, you can refer to the unique paths discussion once. So the difference here is that we can also see optimal substructure here. The minimum cost from the first cell can be calculated if we have the minimal or the optimal solution from cells below it and towards the right. So we can say that this also follows optimal substructure. So the first obvious solution is to apply DP and memoize our recursive solution. So let's go through the code, and I will first remove these red markers which are hiding the memoization. So as always in memoization, what we do not calculate a subproblem again if we have already calculated it. So if we have already calculated the minimum cost from a particular cell, we don't calculate it again. So for storing the minimum cost from a cell, we first declare our map. So the key is int comma int, which is going to be a pair of I comma j, which is the combination of the row and column index of a cell we have already calculated, and the value is going to be int, which is going to be the minimum cost from that cell. So first we check in our map if we have already solved this subproblem, if we have already calculated the minimum cost from this cell. If that is the case, then we simply return whatever is stored in the map. Otherwise we'll solve it recursively, and once we have solved it recursively and once we have found the answer, we'll make an entry in the map so that we don't solve it in the future. So this is the memoization solution for this problem. So now coming to the recurrence relation, let's say that function I comma j gives us the minimum cost from I comma j to the end cell. So I comma j is equal to minimum of cost from I plus 1 comma j, or I comma j plus 1, minimum of these two costs plus the cost of current cell, right? The base case is if I is equal to m minus 1 and j is equal to n minus 1. This is when we have reached the last cell. Then simply f of I comma j should return the cost of that cell because this is the last cell. So this is basically our base case, and this is the recursive case. Now few things before moving to the tabulation solution. From recurrence relation, we can easily see that it can be represented by a matrix because every state is represented by I comma j. So now since we have to solve the problem bottom up, so which problem to solve first? So clearly a cell depends on the right and down. So to calculate the cell, the bottom and the right cell should have already been calculated. So clearly we need to fill this matrix right to left and bottom to up. So in this direction we should fill our matrix. Another way to look at it is that we always start from the base case and keep calculating above. So base case in our logic is the bottom right corner. So we need to start from there. So let's fill an example bottom up, and after that we'll go through the code. So let's fill this matrix only, and we'll try to fill it bottom up, and we'll try to fill it for this particular example. So for the base case, which is the bottom right corner, we have already discussed the value is going to be the value in the matrix given to us. Now for this particular cell, it is going to be the minimum of the value of the cell on right, on of the cell on bottom, plus the value stored in this particular cell. So on the right, we have 1. Bottom we have no cell, so this we are not going to consider. So the minimum of these two is going to be 1 plus the value of the cell itself. So the answer here is going to be 3. Again, for this particular cell, we'll see the cell on the right and on the bottom there is nothing, so obviously the minimum of these two is going to be 3. So we'll take 3 plus the value of this particular cell, so it is going to be 7. Now similarly, these particular cells will also be filled in this way because there's no cell on the right, so we'll only consider the down one. So 1 plus 1 here 2, and 2 plus 1 3. Now for this particular cell, we'll see the cell on the right, which is this cell, and the cell on the bottom. So on the right the value is 2, and on the bottom the value is 3. So we'll take minimum of these two, which is equal to 2, plus the value stored in this particular cell, which is 5. So the value here is going to be 7. Now again, for this particular cell, we'll see this value and this value. So both have 7. So minimum of these two is going to be 7 plus the value of the cell itself, which is going to be 8. Again for this cell, 3, 7, minimum is 3 plus the value of the cell, which is going to be 3 plus 3, which is going to be 6. For this cell, minimum is 6 plus the value of the cell itself. So 6 plus 1, 7. So the minimum cost that we are going to get for traveling from this particular cell to the bottom right corner is 7. So our answer should be 7, which is the correct output. So let's go through the tabulation code. So as we have already discussed, we'll define a matrix for solving the tabulation problem, and the size of the matrix is same as the size of the grid that has been given to us. And we'll initialize or hard code the base case. Base case is the last cell, and the cost for last cell is equal to the value stored in the grid for the last cell. So as we saw while filling up the example, the bottommost row and the last column had only one option, because when we are in the bottom row, there's nothing below it, and when we are in the last column, there's nothing on the right of it. So we are handling the last row and last column separately, and because there's only one option, and we are filling up the values for these separately. So here we are actually filling up our bottommost row, and here we are filling up our last column. Here we only have one option, so we are taking the value below it or on the right and adding the value in the cell itself. Now for all other cells, we are going to follow our main logic. We have to find the minimum out of the right and the bottom cell, and whatever is the minimum, we'll take that value and add the value of the current cell in it, and that is going to be the answer for that particular cell. So we'll fill it bottom up for all the other cells, and finally whatever is the value stored in the first cell, because that is going to be the minimum cost from that cell to the last cell. Whatever value we have in the first cell, we are going to return that value finally. Now time complexity again is very similar to the unique paths problem. Tabulation space and time is big O of m into n, where we have m rows and n columns, because we are using a helper matrix and we are filling the entire matrix one. So time complexity and space complexity is m into n. And memoization is also solving each subproblem once, and total we have m into n subproblems. So the time complexity for memoization is also big O of m into n. With this, we have reached the end of this video. I'll see you in the next video then. Take care. Bye bye.